Hello, Steps Class. Here's 13.1c, already to the third lesson of this unit. So, we are going to talk about technology, because we had this really difficult lesson in Part B that was Step 3, do, and it was these long, ugly formulas, and I want you to know that people that do statistics for a living, statisticians, do not use that formula generally, unless they're maybe programming a computer to teach the computer how to do it, but once the computer knows how to do it, they make the computer do it for them. They don't do it by hand. So I was a little bit mean and I made you learn how to do it by hand, but people who do this for a living use technology. So we're going to talk about how to do Step 3 with technology. And notice I didn't really teach you how to do Step 4 because you already know how. We did it in the warm-up because I was sure that you could handle that. So we're mostly focusing on Step 3 because it's the hard part. We're going to talk about the calculator and then the computer. So calculator does have a shortcut for Anova. You put your data in some lists. And you've done that before. Before this chapter, you mostly did list 1 and list 2. And then, of course, if there's 3 populations, then you would need list 3. And if there's 4, you would need list 4, and so on. And when we do 13.2 next week, I'll talk about what happens if there's more than the 6 that are built into the calculator. That's kind of fun. But then you go to stat tests, and Anova is one of the options. And so let's do that. In fact, the data that I have in my calculator right now came from the warm-up for 13.1a, which was the flowers, and these are the number of new leaves on the flowers for nitrogen and phosphorus and both, and then list 4 is the neither, and remember that list was 1 shorter than the rest because of the monkey. So that's the data that I have already entered in my calculator, and I'm just going to show you how this stat test thing looks. Go to stats, go to tests, and gee, we've learned almost everything on this list, haven't we? We did all that stuff already. And there are actually, you know what? There are 2 things on this list that we have not learned before. 2 sample F-tests we are not going to learn this year. It's an advanced thing that you'll learn more if you take more stats in college. But the very bottom one on this list is Anova, and believe it or not, we have learned everything else on this list. It's all on your mega chart somewhere. Except for not Anova. We're going to do Anova right now. Now Anova is different from the rest because it doesn't have this dot 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 thing. Instead it has a parenthesis, and when you hit enter, it doesn't go to a menu like the other ones. It goes to the home screen, and it's saying, tell me what to do. You know, it's not going to give you a lot of hints, and the reason is that how would you know how many things to put on that menu for how many different populations you have? The calculator doesn't know that. So what you do is you come over here and you tell it you want list 1, that's second 1, comma, which is above the 7, I hope you knew that already, second 2, comma, second 3, comma, second 4. That's how you tell it which lists it needs to look at to do these calculations. So once you tell it that, you choose Anova, let's just finish writing this, and you tell it to look at your list 1, list 2, however many lists you have, you tell it to look at them. And you can keep this going as long as you need to. And like I said, we'll talk about that later. And you hit enter. And I will say that the calculations I did in 13.1b had some round-off error in them because the means were rounded, and then that caused F to come out a little different than it is here, but it's almost the same thing. So my F test statistic is 3.44. My p-value is 0.0307. And when I did it before, I got 3.69 and 0.24. It's because of the round-off error. This is more accurate than the other one. And so then, of course, we would look at this p-value, and we would use that to reject the null. That, I told you I wasn't going to spend a lot of time on step 4. That the mean number of leaves is the same for fertilizer. I'm just going to do that just so that I have the end of that significant test. And of course you would say because this is less than 0.05. Yeah, that's the part that I feel like you already knew. Now the calculator gives you a lot more than those two things. Those are the main two things you need. But then if you scroll down on the calculator, you can get more details. And I want to talk about that because the details are kind of interesting, I think. So what else does it tell us? It has this section called factor, which I'll talk about what that means in just a minute. And it tells us that for factor, the DF is 3, and SS is 27.2, and MS is 9.07. And if I keep going down, then it has another section. Can you see this? Yes, you can. Then it has another section that says error. And I'm going to put that over here, I guess. For error, it says that DF is 27 and SS is 71.18 and MS is 2.64. And then it gives us this thing called SXP that I'm going to have you just ignore. We don't need that number. It's the pooled standard deviation, but you don't need it. Don't worry about it. So these details are kind of interesting because we've learned how to do a whole bunch of stuff in the notes that you just did. And we got slightly different answers. We got an MFG of 9.75 that came from 29/3 or so. This is the more accurate version of that same thing. This is the top and the bottom of the MS fraction, mean squares for groups. Factors are also called groups. This is talking about the good variation, the variation between groups. So some computers call it factors, some computers call it groups. I've seen this written as MSF or MSG or MST for treatments. I've seen it written several different ways. SS is the sum of squares before you divide by the DF. But that's where those numbers are. It's telling you those numbers, and it's a little disappointing that my roundup error made them not come out the same. Sorry about that. Error, as you might have guessed, is the same thing we talked about before. This is MSE right here. This is MSE, and this is MSG that we learned how to calculate in the last lesson. And error is the bad variation, or the variation within groups. So I wanted to point out that the calculator does all that. It's just, it also combines these together and combines these together and divides them and does good over bad. I did it backwards just now. That good over bad, not bad over good, to get the F, and then it does the p-value for you. So all of that, the most important piece is right here. But this is sometimes useful. So there you go. That's what the calculator will do for you. And I suppose if you were asked to do the long, ugly stuff that you did yesterday and you knew the calculator shortcut stuff, you could do that. I won't tell you what you did. Let's talk about the computer. There are lots of software programs out here that do this. And the computer output looks the same every time, pretty much. It always has the source of variation. And then it has the DF. So these should sound very familiar to you. It has the DF, and it has the SS, and it has the MS, and it has the F, and it has the P. And it makes a little table out of them. So this, under source, you will always have the name of your predictor variable, which in this case was fertilizer, which is basically telling you what the groups are. The groups are the different fertilizers. And then it will have error. And then it will have these same numbers that the calculator spits out. DF for fertilizers is 3. Remember that was 4 minus 1. DF for the errors is 27, which is the 31 total sample sizes put together minus the 4. The computer usually adds those together, and you don't need to worry about the total. The total is not important for this class, except for one thing that I'll show you in chapter 14. But yeah, they add them together. SS's are 27.2 and 71.18, and MS's are 9.07 and 2.64, and the F obviously is 3.44, and the P is 0.0307. These two spots are always blank. We're going to ignore them. Sometimes the computer adds these together also. I'm not sure what that's for, so we're not going to worry about it. So I want to remind you that the MS numbers come from the SS divided by the DS. It's a fraction, and then you take the fractions and make a fraction out of them. So this number comes from MSG, the groups, divided by MSE. And then this number comes from FCDF, like we learned in the last lesson. There's S, and 999, and GF1, and GF2. That's okay. So you already knew how to do this. The main reason I'm reminding you of that is one of my favorite type of questions to put on a quiz, hint, hint, is I like to give you this table with some numbers missing. So like maybe I give you that piece, and I say fill in the rest. And you would have to know to do this divided by this to get this, and this divided by this to get this. Or I might give you these ones and leave out these ones and make you work backwards. Or I might give you these ones and make you find F. Or I might give you F and make you find P. Any one of these, once you have this information, you can do the rest pretty easily. This is the hard part, is finding the SS numbers with that long, ugly formula. But once you've got SS, you just divide it. In fact, do I want to write that somewhere? No, I won't. I'll just say it. Reward the people watching the video. Divide this divided by this to get this one. That's the main thing. And divide these two to get that. So you could find missing pieces of the table if you needed to. That's what I'm trying to say. And that is it, believe it or not. All the stuff we're going to do with Anova in 13.1, we're going to do an application of it in 13.2 and a review and a quiz next week. But that's the last of the teaching you how to do it. We'll practice on Tuesday.